Our planet appears to be experiencing a catastrophic tectonic crisis of unprecedented scale. For the first time in 140 million years of Earth's history, scientists have observed an event capable of permanently reshaping global geography. Geologists from various countries are sounding alarms, warning that the Indian continental plate is literally splitting right beneath our feet. Over 2 billion people reside above this slow-moving geological ticking time bomb, unaware of the danger. Each year, the Indian plate shifts roughly 5 centimeters, steadily accumulating strain that could unleash a seismic event exceeding 9 on the Richter scale. An earthquake far more powerful than the Dve-Tisichitira disaster that claimed 250,000 lives. Scientists admit they didn't even realize such continent-wide movements were possible, yet today the evidence is undeniable. This fault line is already making itself felt. Cities are sinking into the ground, and the Indian capital, along with nearby large settlements, are rattled by tremors. But the fracture in the Indian plate extends for miles, tearing open a sprawling fissure. What you're witnessing isn't science fiction. This is happening now, while you watch. If this rupture activates fully, it could impact not only India but neighboring countries as well. There's a real danger that this seismic event might trigger a chain reaction, with tremors traveling across borders, reaching even Russia, posing a new threat from a region once thought geologically stable. The unfolding geological catastrophe along the Indian plate threatens to transform the planet's face forever. What is happening right now with the Indian tectonic plate is astonishing even to experienced geologists. The continent is literally splitting into two. For decades, scientists dismissed this region as relatively peaceful. The Indo-Australian plate was considered a stable, slowly moving mass toward Europe. But recent events reveal a far more dramatic reality, one where kilometer-thick ocean waters conceal processes indicative of a budding new tectonic boundary. This is an extremely rare occurrence, so extraordinary that modern science records it as a first in history. This continental shift began millions of years ago. About 140 million years back, India was part of the massive supercontinent Gondwana, situated near Antarctica in the cold southern latitudes. It's hard to believe, but the landmass now forming tropical India once lay virtually at the South Pole. Then, an astonishing geological odyssey commenced. As Gondwana disintegrated, India separated from its neighbors at an extraordinary pace, approximately 20 centimeters annually, roughly 10 times faster than most tectonic plates move today. Over 100 million years, India traversed roughly 2,000 to 3,000 kilometers across the Indian Ocean, a colossal continental drift. The consequences of this voyage are visible today in the form of the Himalayas, the tallest mountain range on Earth, soaring higher and still rising at about 4 millimeters annually. This ongoing collision with Asia continues to sculpt the landscape, embodying the tremendous forces at play within our restless planet. Over the years, the Indian plate has been gradually rising, yet what initially seemed like the conclusion of a chapter surprisingly marked only the beginning of a more complex phase. Recent scientific studies reveal that the immense pressure exerted by India on the Eurasian plate is so formidable that it is causing the Indian plate itself to fracture. This cracking event is unlike the slow surface splitting observed in Africa, where a continent gently rifts apart over time. Instead, a novel process is at play. The plate is fracturing horizontally, resembling a layered cake splitting into slices. Meanwhile, the upper part continues to press downward against Eurasia, supporting the Tibetan Plateau, while the denser lower section begins to melt into the Earth's partly broken mantle. This revelation challenges traditional views of plate tectonics, suggesting a more intricate mechanism at work. Scientists have identified signs of a vertical fault along the boundary between two sections of the plate, pointing to a potential fracture zone near northern India and Bhutan. On April 11, 2012, the seismic world was shaken to its core. That day, two colossal earthquakes of magnitudes approximately 8.6 and 8.2 struck beneath the Indian Ocean, causing widespread devastation across northern Sumatra. These destructive waves reverberated globally, yet what made this event extraordinary was its location. The quakes occurred well within the interior of the plate, far from any subduction zones. Typically, such powerful earthquakes occur at plate boundaries where one tectonic mass dives beneath another. But these tremors, happening about 100 kilometers from the nearest subduction zone, puzzled geologists. The seismic waves from these quakes exhibited a rare horizontal movement with minimal vertical displacement, a type of event scientists call a strike-slip earthquake. Such large-scale lateral shifts had never been recorded before in seismic history, making this a landmark in seismology. In the subsequent months, researchers analyzed all regional quakes dating back to December 2024, the month when a magnitude 9.1 earthquake triggered a catastrophic tsunami. Their findings were startling. Between 2004 and 2012, the region experienced nearly 10 times more earthquakes than during the previous 8 years. Most notably, 26 of these shocks bore similarities to the April 2012 events, displaying consistent tectonic movement patterns. It was as if the Earth's crust was preparing for a monumental shift, and indeed, a significant and unprecedented event was unfolding beneath our feet. For enthusiasts interested in Earth sciences and anomalies, there is a specialized Telegram channel where exclusive content is shared. Items that, for various reasons, don't make it onto mainstream platforms. Satellite imagery, insider insights from analysts, strange and potentially dangerous phenomena. This material is intended to prompt reflection on the ongoing transformations happening on our planet. Interested viewers can find the link in the description and in the pinned comment below. Recent data analysis reveals that a new tectonic boundary is forming in the Bassin-Orton region, an area situated within the Indian Ocean between India and Australia. Researchers have identified 62 enormous basins created by tectonic shifts along a 350-kilometer fault zone. Some of these depressions stretch up to 3 kilometers in width and 8 kilometers in length. Comparable in size to large cities, yet they vary significantly in depth. This disparity indicates that the fault is more active in its southern segments, where the crust is literally tearing apart with increasing intensity. The new fault is expanding at a rate of 27 millimeters annually. To put this in perspective, the San Andreas Fault in California moves 10 times faster, and the Dead Sea Fault advances twice as quickly. Despite its comparatively slow pace, such activity can still trigger catastrophic consequences for millions. The April 2012 earthquake demonstrated how powerful these events can be. It surpassed all scientific expectations. The U.S. Geological Survey's Fred Poles reported that within 6 days after the earthquake on April 11th, seismic activity of 5.5 magnitudes and above increased nearly 5-fold worldwide. This marked the largest surge of its kind ever recorded. Nature seems to follow a domino effect. One major quake can set off a cascade of seismic disturbances across continents. Seismic waves from this March event activated dormant faults stretching from California to Turkey. Currently, the activity of the Indian plate threatens not only regional geological stability, but also the lives of nearly 2 billion people. Experts warn that an impending major earthquake in the Himalayan region could become one of the largest natural disasters in human history. The potential scope of such a catastrophe is staggering. The entire Himalayan belt is considered highly vulnerable to quakes exceeding 8 magnitudes. For comparison, the 2023 earthquake in Turkey and Syria registered between 7 and 8 in magnitude, causing around 45,000 fatalities. The Himalayan earthquake could be even more powerful, affecting dozens of cities across multiple countries. Signs of instability are already evident in the region. In the Indian town of Joshimath, located within the Himalayan foothills, residents are witnessing disturbing phenomena. The ground appears to be crumbling beneath their feet as enormous cracks snake along streets, and foundations of about 500 homes have been damaged. Authorities are conducting regular evacuations, but the process of ground subsidence remains uncontrolled. Even the Indian capital, New Delhi, is not immune to seismic activity. On February 17, 2025, the city experienced a 4.0 magnitude quake, the strongest in the past 5 years. Many residents reported unusual sounds during this event, reinforcing fears that a different and potentially more destructive kind of quake was unfolding. Delhi lies within India's 4th seismic zone, which is classified as the second most dangerous region due to its vulnerability to earthquakes. As the seismic threat in the Himalayan region persists, the possibility of a major quake looms, raising concerns about widespread destruction and loss of life across South Asia. A major earthquake can cause severe structural and infrastructural damage during its strongest tremors. In the national capital region of Delhi, which is home to over 30 million people, such an event could lead to catastrophic consequences. The situation in the Indian Ocean basin is similarly tense, with recent developments highlighting increased seismic risks. An active new system of fault lines forming between the Indian and Arabian plates elevates the likelihood of both earthquakes and tsunamis. French geologists have identified an 800-kilometer-long fault zone that remains active and frequently triggers large underwater landslides on the seabed of the Mediterranean. This hazard is especially pronounced along the western edge of the Oman ophiolite, where numerous signs of submarine landslides appear. These underwater avalanches consist of intact blocks of rock, roughly 100 meters high and up to 2 kilometers long, each weighing millions of tons. Such massive geological movements pose risks of triggering tsunamis along Oman's coast and neighboring regions in the Arabian Peninsula. Recall the devastating tsunami of 1914, caused by an earthquake offshore of Sumatra, which remains vivid in the collective memory. This submarine event, with a magnitude of approximately Simtochka Tri, became one of the deadliest natural disasters in recorded history. A shift of the Indian plate beneath the Burmese plate, spanning about 1,200 kilometers, violently disintegrated large amounts of rock, generating waves up to 30 meters high. What we observe with the Indian plate is only part of a broader tectonic rearrangement affecting the entire planet. Seismic analysis of waves in the region reveals a complex picture. The mantle has fractured into 4 distinct segments. This discovery explains why powerful earthquakes occur selectively in certain areas rather than uniformly across the region. Beneath the Deccan Plateau, these upper mantle layers contain 4 major faults where the descending Indian crust moves at different speeds and in varying directions. These differential movements create intricate stress patterns, periodically releasing energy as intense seismic events. Meanwhile, the eastern part of Africa, situated on the Eastern African Rift System, is undergoing a tectonic revolution that could eventually lead to the emergence of a new ocean basin within millions of years. The East African Rift is expanding at roughly 6 millimeters annually, which is 4 times faster than the Indian Ocean's creasing Indian Plate. Concurrently, significant changes are also occurring in the world's oceanic crust. British research utilizing the HMS Scott, a military vessel equipped with advanced seismic sensors, documented extensive underwater alterations linked indirectly to the 1994 Indian Ocean earthquake and tsunami. A colossal submarine landslide, roughly 1,500 meters high, collapsed into the seabed, forming vast scars several kilometers wide across the ocean floor, visual evidence of the planet's ongoing inner upheaval. These seabed modifications influence ocean currents with potential long-term impacts on the global climate. Tectonic plates do not merely drift passively, they interact in a complex network, influencing each other across thousands of kilometers. As we have seen, an earthquake in one region can awaken dormant faults thousands of miles away, triggering a cascade of seismic activity elsewhere. This interconnectedness underscores the delicate balance of Earth's dynamic systems, highlighting that tremors in one part of the world can set off chain reactions far beyond their initial epicenters. The future holds a potentially terrifying scenario, far more alarming than any science fiction. Computer models reveal a striking vision of Earth's distant destiny. In roughly 50 million years, Africa and Australia will drift close enough to Eurasia to form a new supercontinent. Subsequently, Antarctica and both the Americas will join this landmass, transforming Earth into a single vast continental expanse surrounded by ocean. A dramatic reunion reminiscent of the supercontinent Pangaea, which existed over 250 million years ago. However, the path to this union will be fraught with pain and upheaval, as each collision between massing landmasses gives rise to towering mountain ranges, surpassing even today's most formidable peaks like Mount Everest. Imagine mountains soaring 15 to 20 kilometers into the sky, where the immense weight would be felt at their summits through destructive pressure. The more unsettling aspect involves the buildup of seismic stress. Each year, the Indian Plate advances roughly 5 centimeters northward into Eurasia, accumulating strain that cannot be contained indefinitely. Eventually, this tension will release catastrophically in a massive earthquake. Seismologists have crafted scenarios predicting earthquakes with magnitudes exceeding 9 on the Richter scale in the Himalayan region. Such a quake could devastate an area home to over 200 million people, from Pakistan through the Bay of Bengal, with aftershocks capable of reaching as far as Russia. Current cities, Delhi, Kathmandu, and Colombo, are ill-prepared for such seismic events, and the economic fallout could eclipse all previous natural disasters. The Himalayan region is not only densely populated, but also supplies fresh water to the third of humanity living downstream. A significant quake might alter river courses, complicating water access from China to Bangladesh and causing widespread humanitarian crises. Moreover, tectonic shifts will influence regional climates by disrupting atmospheric patterns fed by these mountains, potentially expanding deserts, shifting rainfall zones, and transforming temperature regimes across vast territories. One of the greatest challenges lies in many nations' inadequate disaster response plans. Building codes often neglect seismic risks, as demonstrated by Turkey's complacency, which allowed the development of entire cities in hazardous zones, with early warning systems functioning only partially. Meanwhile, the Indian plate continues its relentless northward march, advancing each day toward new geological frontiers. Eventually, this slow but persistent movement will push Earth into an entirely different geographical configuration. If this topic captivated you, consider reflecting on the immense forces shaping our planet, forces that could redefine its surface and threaten billions.